Welcome to the Tyre Recycling Podcast, the leading video podcast series brought to you by Tyre and Rubber Recycling. Ewan Scott, our publisher for the magazine, is here to join me as ever. Ewan, how are things?
Things are fine across here. I'm enjoying the typical English summer weather. It's pouring non-stop.
Some things never change. But last time out on the podcast, we were able to treat you as an extended interview with Peter Taylor. Today, however, we're going to be diving back into the world of tyre pyrolysis, and specifically, we're going to hop across the pond to the US. So, what have we got up our sleeves today?
Today, we're talking to Bryce Powell from New Green Technologies Inc., an American company that is looking at high-volume microwave pyrolysis. It's a new project, and it'd be interesting to hear what Bryce has to tell us.
Definitely, that sounds good. Is there anything that you're particularly looking forward to finding out from Bryce, and anything in general about New Green Technologies?
I'm really interested in the concept of the high-volume microwave technology. It's a technology that's been around for a long time, microwave technology, that is. But 10 years ago, it would take a microwave the size of a small classroom to microwave one tyre, and an awful lot of energy. And that's what held things back. Now we're starting to see microwave technology working. It would be interesting to see what Bryce has got to tell us.
Definitely. Well, I look forward to that and seeing what Bryce has to say regarding microwave technology and his process in particular. And I'm sure that'll make for fascinating viewing. But we'll stop our talking and we'll lead on with the interview with Bryce Powell, the CEO of New Green Technologies.
This is Ewan Scott from Tyre Rubber Recycling magazine. Today we're speaking to Bryce Powell. Bryce is involved with microwave technology, and we'd love Bryce to tell us a bit more about what he's doing.
Ewan, thank you. Thank you for welcoming me to your show. New Black Technologies has developed and patented a continuous microwave pyrolysis process. We built a prototype which was tested in Ohio over the course of a year and a half, and now we're getting ready to go into production, raising capital to build a plant in the United States.
Okay, so you've gone through the pilot process, and you now have to commercialize it and fund the development of a full-scale plant.
Yes, that's correct.
Okay, so what sort of tonnage do you expect to be going through at this plant?
Each line of equipment will process 60 tons of chipped tire material per day. And so for our plant, in terms of the scalability, we're looking at building a 3-line plant that will do 180 tons of tires material a day. That's around 7 million tires per year.
That's a big undertaking. Certainly by European standards, that's a big plant.
Yes.
Okay, and you're taking in chip tire for this. What sort of size?
3/4 inch or 2.5 centimeters. Wire liberated is our specification.
Okay, and you having that supplied by local shredding companies?
Yes, we have entered a memorandum of understanding with one of the largest waste tire processors in the United States.
I can guess.
There's only a handful.
Okay, so when would you hope to be in production?
We probably about a year and a half after funding. And, I believe we're getting close on that. And so I'm hoping within the next 2 years, we will be in production.
Right, that'd be interesting to see. The development of microwave technology has come on somewhat. I first talked to people about microwave pyrolysis a good 15, 16 years ago, and they were talking about a good room-sized oven, microwave oven, to pyrolyze one tire. So I'm presuming that the process has come on quite some way. That you can look at processing that sort of volume of material.
Yeah, frankly, I think we have the most advanced technology that I'm aware of in the world. It is big. What happens is these tire chips, they go up a conveyor, they go through an in-feed auger, and then they move through our system, which has three ovens or three applicators. Each one of them is, maybe half the size of the back of a container on a semi. So, it's fairly large scale. And with that, we're going to have a modular refinery to refine our oil on site into diesel and naphtha. Of course, the recovered carbon black is our main commodity, and we produce a syngas that's very clean. We can generate enough electricity to run the entire system with excess to sell. Our syngas is mostly methane, very similar to the composition of natural gas.
Okay, so once you have the plant up and running, it's a continuous plant, you say. Once you have it up and running, it becomes almost a perpetual operation. You're not having to add new energy to it. It generates its own energy.
That's correct. We intend to run 28 days a month, a couple of days of downtime for cleaning and maintenance, but otherwise running continuously.
Okay. And where will this plant be located?
Near Philadelphia, Pennsylvania.
Right. Okay. So you have a ready market for the steel then?
We are not. Yes, there will be a ready market for the steel. Our partner, our supplier, will be able to service that market because they'll liberate the steel and just deliver chips to us.
Right.
We don't actually handle a tire.
Of course. Okay. So we're talking to you because we don't know anything about your business or what you're doing. So this is all new to us. Microwave technology is something that is growing. We know of a couple of processes in the Ukraine, both of which have fallen at the hurdle of funding, and one development process in Italy. So if you're ready to commercialize, you could be well ahead of the competition in that market. What are the advantages of your microwave technology over conventional thermal technology?
Our advantage really is in the efficiency. It's just like in your kitchen. If you were to heat a frozen burrito, it would take about 30 minutes in a conventional oven, 30 seconds in the microwave. We can process these tire chips from end to end in 1 hour. I think with conventional processes, particularly batch processes, you're looking at more like 8 hours to process that. Also, the mechanism of microwave heating is different. Thermal heating, of course, is surface heating. It acts on the surface first and then works its way inward towards the core. Microwave heating starts on the inside and actually excites the molecules themselves, generating the heat from inside the material. And we believe that results in a better quality carbon black because the carbon black does not have the damage to the surface or the carbonaceous crust caused by thermal heating. And so our belief is that ours has more surface activity as well.
So you can produce a recovered carbon black with a greater surface active area. And what can you tell us about its dispersibility in new rubbers, new compounds?
Not a lot at this point. We do have some information, but application development is something that still needs to be done.
Right. The application is always a tricky bit.
Yeah.
It's persuading the market that your product's the right thing. Are you involved with the ASTM D36 committee?
I'm not personally involved. I do try to keep abreast of their meetings and what's going on there. You know, one thing I'll say is I'm very thankful to the people developing the thermal technologies, because they're breaking barriers for the entry to market, and you know, so they're creating a market for recovered carbon black and making it more acceptable.
Okay, so you will have a ready market for the oil that you produce. You should have a market for the carbon that you produce. Have you an idea of what sort of equivalency it is to, for argument's sake, N330?
You know, roughly, I think in terms of its colloidal properties, the particle sizes are similar to an N330. Performance-wise, my understanding is it's capable of replacing N500, 600, and 700 series.
Okay, right. It will be interesting to see how things develop, and you've given us some information. We can put this together, and I'm sure people in the pyrolysis world for sure will be interested in hearing what you're doing.
And there you have it, our full interview with Bryce Powell, the CEO of New Green Technologies. Ewan, what did you make of our first introduction to Bryce?
That was an interesting interview. They're at early stages of the project, but they've got big plans. It would be interesting to go back to them in maybe 18 months' time when they've got the plant up and running, and see just how well they're going with their high volume microwave pyrolysis technology.
Definitely, I'm sure we'll be able to catch up with Bryce in the future to see how the project has progressed. But moving on from today's podcast, could you give our viewers a little hint into what they can expect from episode 9?
Episode 9, we interview David Ashurst and Jerry Kearney from UK Rubber, a new start in Scotland with plans to be perhaps the main processor of tires in Scotland in the future. They have ideas of a plant that will process some 50 to 60,000 tons of tires per year, which equates almost to the full Tyre risings for Scotland.
Okay, well, I'm certain that'll be a good watch, and yeah, I'm sure that'll make for good viewing for our viewers. But thanks for your time today, Ewan, and we're going to be back very shortly with another installment of the Tyre Recycling Podcast.